Why are scripting languages, for example Perl, Python, and Ruby, not suitable as shell languages? What are the differences between shell languages like Bash, Z shell, ZSH, Fish, and the scripting languages above that makes them more suitable for the shell? When using the command line, the shell languages seem to be much easier. It feels for me much smoother to use Bash for example than to use the shell profile in IPython, despite reports to the contrary. I think most will agree with me that a large portion of medium to large scale programming is easier in Python than in Bash. I use Python as the language I am most familiar with. The same goes for Perl and Ruby. I have tried to articulate the reason, but I am unable to, aside from assuming that the treatment of strings differently in both has something to do with it. The reason of this question is that I am hoping to develop a language usable in both. If you know of such a language, please post it as well. As s.lot explains, the question needs some clarification. I am asking about the features of the shell language versus that of scripting languages. So the comparison is not about the characteristics of various interactive, REPL, environments such as history and command line substitution. An alternative expression for the question would be: can a programming language that is suitable for design of complex systems be at the same time able to express useful one-liners that can access the file system or control jobs? Can a programming language usefully scale up as well as scale down?
There are a couple of differences that I can think of, just thought streaming here, in no particular order. Python and Co. are designed to be good at scripting. Bash and Co. are designed to be only good at scripting, with absolutely no compromise. Python is designed to be good both at scripting and non-scripting. Bash cares only about scripting. Bash and Co. are untyped, Python and Co. are strongly typed, which means that the number 123, the string 123 and the file 123 are quite different. They are, however, not statically typed, which means they need to have different literals for those, in order to keep them apart. Example: Python and Co. are designed to scale up to 10,000, 100,000, maybe even 1 million line programs. Bash and Co. are designed to scale down to 10-character programs. In Bash and Co., files, directories, file descriptors, processes are all first-class objects. In Python, only Python objects are first-class. If you want to manipulate files, directories etc., you have to wrap them in a Python object first. Shell programming is basically data flow programming. Nobody realizes that, not even the people who write shells, but it turns out that shells are quite good at that, and general-purpose languages not so much. In the general-purpose programming world, data flow seems to be mostly viewed as a concurrency model, not so much as a programming paradigm. I have the feeling that trying to address these points by bolting features or DSLs onto a general-purpose programming language doesn't work. At least, I have yet to see a convincing implementation of it. There is Rush, Ruby shell, which tries to implement a shell in Ruby. There is Rush, which is an internal DSL for shell programming in Ruby. There is Hotwire, which is a Python shell, but none of those come even close to competing with Bash, ZSH, Fish and Friends. Actually, the best current shell is Microsoft PowerShell, which is very surprising considering that for several decades now, Microsoft has continually had the worst shells ever. I mean, command.com? Really? Unfortunately, they still have a crappy terminal. It's still the command prompt that has been around since, what? Windows 3.0? PowerShell was basically created by ignoring everything Microsoft has ever done, command.com, cmd.exe, script, JScript, and instead starting from the Unix shell, then removing all backwards compatibility cruft, like backticks for command substitution, and massaging it a bit to make it more Windows-friendly, like using the now unused backtick as an escape character instead of the backslash, which is the path component separator character in Windows. After that, is when the magic happens. They address problem 1 and 3 from above, by basically making the opposite choice compared to Python. Python cares about large programs first, scripting second. Bash cares only about scripting. PowerShell cares about scripting first, large programs second. A defining moment for me was watching a video of an interview with Jeffrey Snover, PowerShell's lead designer, when the interviewer asked him how big of a program one could write with PowerShell, and Snover answered without missing a beat, 80 characters. At that moment I realized that this is finally a guy at Microsoft who gets shell programming, probably related to the fact that PowerShell was neither developed by Microsoft's programming language group, i.e. Lambda Calculus Math Nerds, nor the OS group, kernel nerds, but rather the server group, i.e. sysadmins who actually use shells, and that I should probably take a serious look at PowerShell. Number 2 is solved by having arguments be statically typed. So, you can write just 123 and PowerShell knows whether it is a string or a number or a file, because the cmlet, which is what shell commands are called in PowerShell, declares the types of its arguments to the shell. This has pretty deep ramifications, unlike Unix, where each command is responsible for parsing its own arguments. The shell basically passes the arguments as an array of strings. Argument parsing in PowerShell is done by the shell. The cmlets specify all their options and flags and arguments, as well as their types and names and documentation, to the shell, which then can perform argument parsing, tab completion, IntelliSense, inline documentation pop-ups, etc. in one centralized place. This is not revolutionary, and the PowerShell designers acknowledge shells like the Digital Command Language, DCL, and the IBM OS/400 Command Language, CL, as prior art. For anyone who has ever used an OS/400, this should sound familiar. In OS/400, you can write a shell command, and if you don't know the syntax of certain arguments, you can simply leave them out and hit F4, which will bring a menu, similar to an HTML form, with labeled fields, drop-down, help texts, etc. This is only possible because the OS knows about all the possible arguments and their types. In the Unix shell, this information is often duplicated 3 times, in the argument parsing code in the command itself, in the bash completion script for tab completion, and in the man page. Number 4 is solved by the fact that PowerShell operates on strongly typed objects, which include stuff like files, processes, folders, and so on. Number 5 is particularly interesting, because PowerShell is the only shell I know of where the people who wrote it were actually aware of the fact that shells are essentially data flow engines and deliberately implemented it as a data flow engine. Another nice thing about PowerShell are the naming conventions. All cmlets are named action object, and moreover, there are also standardized names for specific actions and specific objects. Again, this should sound familiar to OS/400 users. For example, everything which is related to receiving some information is called getFoo. And everything operating on subobjects is called bar child item. So, the equivalent to ls is getChildItem, although PowerShell also provides built-in aliases ls and dir. In fact, whenever it makes sense, they provide both Unix and cmd.exe aliases as well as abbreviations, GCI in this case. But the killer feature emo is the strongly typed object pipelines. While PowerShell is derived from the Unix shell, there is one very important distinction. In Unix, all communication, both via pipes and redirections as well as via command arguments, is done with untyped, unstructured strings. In PowerShell, it's all strongly typed, structured objects. This is so incredibly powerful that I seriously wonder why no one else has thought of it. Well, they have, but they never became popular. In my shell scripts, I estimate that up to 1/3 of the commands is only there to act as an adapter between two other commands that don't agree on a common textual format. Many of those adapters go away in PowerShell, because the cmlets exchange structured objects instead of unstructured text. And if you look inside the commands, then they pretty much consist of 3 stages: parse the textual input into an internal object representation, manipulate the objects, convert them back into text. Again, the first and third stage basically go away, because the data already comes in as objects. However, the designers have taken great care to preserve the dynamicity and flexibility of shell scripting through what they call an adaptive type system. Anyway, I don't want to turn this into a PowerShell commercial. There are plenty of things that are not so great about PowerShell, although most of those have to do either with Windows or with the specific implementation, and not so much with the concepts. For example, the fact that it is implemented in .NET means that the very first time you start up the shell can take up to several seconds if the .NET framework is not already in the file system cache due to some other application that needs it. Considering that you often use the shell for well under a second, that is completely unacceptable. The most important point I want to make is that if you want to look at existing work in scripting languages and shells, you shouldn't stop at Unix and the Ruby/Python/Perl/PHP family. For example, TCL was already mentioned. Rex would be another scripting language. Emacs Lisp would be yet another. And in the shell realm there are some of the already mentioned mainframe/midrange shells such as the OS/400 command line and DCL. Also, Plan 9's RC.
It's cultural. The Bourne shell is almost 25 years old. It was one of the first scripting languages, and it was the first good solution to the central need of Unix admins, i.e., a glue to tie all the other utilities together and to do typical Unix tasks without having to compile a damn C program every time. By modern standards, its syntax is atrocious and its weird rules and punctuation a statement style, useful in the 1970s when every byte counted, make it hard for non-admins to penetrate it. But it did the job. The flaws and shortcomings were addressed by evolutionary improvements in its descendants, KSH, Bash, ZSH, without having to reconceive the ideas behind it. Admins stuck to the core syntax because, weird as it was, nothing else handled the simple stuff better without getting in the way. For complex stuff, Perl came along and morphed into a sort of half-admin, half-application language. But the more complex something gets, the more it's seen as an application rather than admin work, so the business people tend to look for programmers rather than admins to do it, despite the fact that the right kind of geek tends to be both. So that's where the focus went, and the evolutionary improvements to the application capabilities of Perl resulted in, well, Python and Ruby. That's an oversimplification, but Perl was one of several inspirations for both languages. Result? Specialization. Admins tend to think modern interpreted languages are too heavyweight for the things they're paid to do every day. And overall, they're right. They don't need objects. They don't care about data structures. They need commands. They need glue. Nothing else tries to do commands better than the Bourne shell concept, except maybe TCL, which was already mentioned here, and Bourne is good enough. Programmers, who nowadays are having to learn about DevOps more and more, look at the limitations of the Bourne shell and wonder how the hell anyone could put up with it. But the tools they know, while they certainly lean towards the Unix-ish style of I/O and file operations, aren't better for the purpose. I've written things like backup scripts and file renaming one-offs in Ruby, because I know it better than I know Bash, but any dedicated admin could do the same thing in Bash, probably in fewer lines and with less overhead, but either way, it'd work just as well. It's a common thing to ask, why does everyone use Y when Z is better? But evolution in technology, like evolution in everything else, tends to stop at good enough. The better solution doesn't win unless the difference is viewed as a deal-breaking frustration. Bourne type scripting might be frustrating to you, but for the people who use it all the time and for the jobs it was meant for, it's always done the job.
A shell language has to be easy to use. You want to type one-time throwaway commands, not small programs. I.e., you want to type not. This, also, means shell languages don't really care if an argument is an option, a string, a number or something else. Also, programming constructs and shells are an add-on, and not even always built in. I.e., consider the combination of if and, in Bash or Bourne shell, sh, sec for generating sequences, and so on. Finally, shells have specific needs that you need less, or differently in programming. I.e., pipes, file redirection, process/job control, and so on.
If you know of such a language, please post it as well. TCL is one such language, mainly because it is designed to primarily be a shell interpreter for CAD programs. Here's one hardcore Python programmer's experience of realizing why TCL was designed the way it was. I can't believe I'm praising TCL. For me, I've written and have been using an improved TCL shell, written in TCL, of course, as my main Linux login shell on my homebrewed router, pure TCL Redline. Some of the reasons I like TCL in general has everything to do with the similarity of its syntax to traditional shells. At its most basic, TCL syntax is command argument argument ... There's nothing else. This is the same as Bash, C shell or even DOS shell. A bare word is considered a string. This is again similar to traditional shells, allowing you to write openmyfile.txt instead of openmyfile.txt. Because of the foundations of 1 and 2, TCL ends up with very little extraneous syntax. You write code with less punctuation, puts hello instead of print hello. When writing programs you don't feel the hurt so much, because you spend a lot of time thinking about what to write. When you use a shell to copy a file you don't think, you just type, and having to type, and, again and again gets annoying very quickly. Note, not me, I'm a hardcore TCL programmer.
If you want to see more, please consider subscribe.